Hello, everyone. I'm Jenny. I'm currently a machine learning team lead with AltaML. We are a company in Alberta. That's what the Alta stands for. And today I wanted to present around the topic of responsible AI, particularly around the idea of AI fairness and AI bias. And this is a bit of agenda. So the first half will be more high level about like why is responsible AI important and why do we even need to care about this. And later, if we do have time, I might get into a little bit to the technical and applications and some of the challenges. Okay, so a little bit of introduction here. Why is responsible AI important and why are we spending our time to talk about this topic? So now every company is everywhere, like everyone you talk to, people are talking about how the machine learning and AI systems have been used to change people's life and also help people to make decisions. And remember that these decisions are going to be used to impact people's life. So it becomes very important for us to make sure that these systems are transparent and fair. It is a practice to create models that are going to be explainable, transparent, and treat people fairly. And this is a practice that ideally should be adopted regardless where you work for, which company you work for, and where you are. And this is why we think this is an important topic to introduce to people, especially data scientists. And here are just some examples of when the biased machine learning AI system can cause some harms. Some of the very famous ones, including hiring in Amazon and school admissions and loan banking approving loans. So if you have systems that are not fair, and if the system's generating outcome that are biased, eventually a group of people will be harmed with this system. And this is very important for data scientists and for all the companies to pay attention to, because there are consequences if you don't pay attention to these areas. It could hurt your reputation as a company, and there may be some legal issues, and there may be unintended consequences in the decision making. At the end of the day, people will not want to trust any decisions AI or machine learning systems make. Okay, so it's changing how we live and how we interact with the world, and we know that it's very important. So how do we make sure that the system are going to be transparent and fair? And before we dive into the questions, what is fair and what is fairness? So if you read some papers or if you do some readings, articles in these areas, there are actually like millions, like so many different definitions of fairness. But in general, we wanted to group this into two types of fairness. One is individual fairness, and the other type is group fairness. In terms of individual fairness, it literally means if you are similar individuals, the prediction outcome should be similar. Individual fairness is challenging because it's hard to define what similar individual means. Like you can have a twin brother and you can call them similar, but there might be some variables that's impacting these two individuals that make them not similar. So this is a challenging part. And group fairness is something that's a little bit easier to tackle. With group fairness, your goal is to treat different people equally, and different groups of people defining by the protected variable equally. And we're going to talk about protected variable later. And this is something that a lot of tools, a lot of existing tools have been implementing algorithms to try to solve this problem. So what are the risks with group bias? So I put two big examples here. One is when you have machine learning servers that can harm a certain group of people. And as we mentioned before, in terms of hiring, school admissions, and lending loan approvals, those are the big ones, because those are the ones that will actually harm certain people. And certain people, because of this machine learning systems biased, and it's going to hurt their opportunities to obtain certain things, either jobs or other school admissions, and even money. And the other type of bias, not necessarily it hurts a group of people in a way like as significant as the first example there, but it still hurts people. For example, you might have a machine learning system to identify people's face, people's emotion, but if it only works for a certain race, it doesn't work for the other race, then that's one example of, even though it's not necessarily hurting people, but not necessarily hurting a group of people, but in this case, certain group of people, they do not enjoy the same amount of quality when they use these servers. Okay, and here we're going to talk about why this is important. So there's often bias in the data that we use. So machine learning, pretty much, they're just like little kids. They learn this bias from the data that will fit into the model. So this data bias, it can come from like either sampling bias, and maybe you only collect data from a certain group of people, and that just introduce sampling bias, or labeling bias, or there are many types of different bias. For example, like historical bias, like previously humans tend to be more sexist or racist, and those kind of data are collected and being fed into the machine learning systems. And when your model is trying to learn this, it's going to exaggerate the data bias there, which makes the situation worse. So this is very important that we do not make this happen. And previously, I talked a bit about protected variables. So people are grouped by protected variable, and that's how we define group fairness. So for example, if you separate a group of people based on the age, based on their gender, or based on their race, you shouldn't have the different outcome just based on this protected variable. So that's what I mean by protected variable. So these are the variables that, at least in Canada, it's against the law to discriminate people using these characters. And these are the characteristics that should be protected when you are building machine learning models as well. Again, I mentioned age, race, gender are big ones, and there are some other ones as well, sexual orientation, religion, pregnancy, and so on. Anything that's against the law to be used to discriminate against people, we should take them into account when we build our machine learning systems. So some people might have an idea of what if we just remove the protected variables? So this is a strategy that previously was used by some researchers, but the thing is, removing protected variable doesn't really prevent the model from learning some of the proxy variable that kind of also have the bias in it. Example is, if you look at the person's resume and you see the year of education, that actually gives you information, sort of gives you information of the age as well. In terms of gender, looking at school names and even looking at some of the gap year, you can kind of guess, oh, maybe the person's taking maternity leave, and you assume that's a female. Those are the situations that even if you totally remove the protected variable, you still don't help. You are still not helping the machine learning model to stay unbiased. So it's very important to understand that there are proxy variables, and we have to take them into account as well as the protected variables. And here are just a bit of case studies of some of the examples of when machine learning systems go wrong. So if you read a lot of papers in this area, this is the example that always come up. The Compass, it's a software that was supposedly to use to help judges to be more fair. So this is a software used to assess likelihood of recidivism among the convicted criminals. And apparently, eventually, it was found out that this system is biased against African Americans. So people who are African Americans were more likely to be misclassified as high risk of violence. So this is something that has to be avoided. And the problem is that when it's human making decisions, we know there's bias in human decisions. But when we just blindly trust our machine learning models without knowing that models, they can learn bias from people too, then we head towards into a very dangerous situation that we are making a certain group of people suffer from our machine learning systems. So this is just a plot of example of how the training that you make, it just thinks that certain group of people that's more like criminal. And this is like how a machine learning system go wrong. So when you have sampling bias, so you collect data from certain group of people, but then the distribution is not the same as real world distribution, and you feed this data to the algorithm, and because of that you generate a bias model, and then you generate prediction, and your judges make real world actions based on those predictions. And this kind of outcome got feeding back into the real world scenarios. So more Black Americans were sent to jail because of this. And the data, it creates more data, more unfair data. And then algorithms learning from this, and it becomes a loop, a really bad cycle. So we need to make sure this thing doesn't happen. Mentioned about just removing the variable, protected variable, don't necessarily solve the problem. Okay, another example, Amazon recruitment AI. They were trying to intentionally not include demographics, but still some of the proxy variables, as we previously mentioned, still contains biased information, and that still makes the final prediction outcome biased. So this is an example in AI Amazon system. It penalized resume that include the words women's because there's like, even though you don't identify this person's women, but because those certain terminologies that help the machine learning model to know that this is likely female, it downgraded everyone that has those like women related terminologies in the resumes. So in that case, that's something that how machine learning can learn from proxy variables and still build harmful machine learning systems. Again, so learning from this is the importance to understand proxy variables impact is just as much as the protected variable, and understand that this idea of equity and equality. And when we're talking about like equality, we want people to be given the opportunities, to given the chance. When it's like equality, it's like, oh, we're just learning the machine learning systems. The machine learning systems just learning real world data. But the thing is that when people are talking about, oh, it's just statistics, you don't understand that in the human history, a lot of bias will fit into the statistics. So the statistics we are seeing contains a lot of bias there. And that's why we need to focus on equity instead of equality. Okay, so we sort of talk about the machine learning system can be used on loan payment, community service, employee ranking. There are other things machine learning systems can still be used to impact humans' life and humans' decisions. So it's very important for us to always take that into account as data scientists to understand how the models we are building can really impact people's life. So a bit of a recap, you have data that contain bias, and then you learn your model learns this algorithm. Your algorithm learns this bias in it, and you generate bias model, and you make prediction and make real world action towards it. And this feedback goes back into the real world, and you got more bias data. And that's why it's so important for us to understand risk of the machine learning bias and data bias. And there are actually a lot of companies, Google, IBM, Microsoft, they were looking into this area. So it's actually really new. Like a lot of companies are looking into this, and I wouldn't say any company really solved this problem, but it's really important for us to understand it's an area that desperately needs data scientists to look into. So some of the methods a lot of companies are doing right now, and it is like, firstly, identify the bias, either it's data bias or model bias. And secondly, being able to explain the bias. So this is where the explainable AI comes from. And third, augment and or like mitigate the bias. So once you are able to identify the bias and explain the bias, it's really good that if you are also able to mitigate this bias as much as you can. With identify, so I was talking about this like data bias and model bias, and with data bias, sampling bias is a big one. So the data you collected is just not the same as the distribution of the real world population. And labeling bias, or even like historical bias, and even bias that happen throughout communication. So I'm sure many of you data scientists here work very closely with business analysts, working with subject matter experts. During those communication, bias can happen as well. And the thing is, the business subject matter experts, they might not understand the concept of machine learning bias, but then they might feeding you information on some of the things that can be biased. But as a machine learning developer or data scientist who might not have the domain knowledge, might have trouble to really identify the bias yourself. So there are so many scenarios that can introduce bias there. And that's why it's really important to educate and make sure everyone involved in building machine learning systems understand this situation. And in terms of modeling bias, so after you have a data bias, and that's fed into a model, and there's modeling bias there. So how do we identify data bias? So if you do have access to the protected variable, then it's actually simpler. For example, if you do have a set of data and you do have access to protected variables such as like gender, age, and those information, you can actually do some simple statistics, just calculations to understand if it's actually the same or similar as what the real world distribution should be. In a lot of cases, some companies, they feel reluctant to share this kind of information to data scientists or machine developers, because they kind of feel it's unethical to share those information. But then we do kind of need those information to identify if there are sampling bias in it. So if you don't have access to that information, it actually makes the problem a lot more challenging. So else, good luck. And in those scenarios, recommendation is really make sure the communication to the business or to the client is there, so they understand the reason why you need to have access to these protected variables. And the reason you have that is to really help to protect those people. If they don't, if clients don't share those information with you, a lot of reason is because they're trying to protect their customers, their clients. But without sharing those informations, the very people they're trying to protect are going to be the very people that's going to be harmed. Okay, so these are just some examples on how you like calculate the fairness, and if there's like bias in the data, simple chi-square method and can calculate the if the distribution is what you expected. And in terms of model bias, there's a demographic parity difference score. So ideally, the score the lower the better. I believe this plot is from Azure's Fairlearn. So this is an example of some companies that they are implementing tools and to help you to identify, to evaluate and to have a score to help you to identify if there's bias in your model. And explain. Again, this is one of the tools. It's either Fairlearn or AIF 360 from IBM. It has this thing to help you to understand which features. If you change the features, if you change the value of the variable or of the feature, how that's going to impact your model. So doing that, it helps you to understand how much the model is relying on certain variables to make the predictions. And for example, if a model is making prediction solely based on, like mostly based on gender or mostly based on age, and then you know there are some bias there, and this machine learning model cannot be used. It's another example here of building a model, and then with this graph, it very clearly shows you what are the variables that has the most impact to your model outcome. Again, like there are some of the toolkits you can go take a look. This Google has what if tools, and there's an interpret. I don't remember what that's from. I don't think that's from one of the big companies, but those are really good tools to help you to explain your models, migrate or mitigate. So some of the tools, they implemented methods that can help you to mitigate some of the model bias or data bias, as pre-process, in-process, post-process, and meta-process. With pre-process, that's trying to handle the bias problem before the data is even being fed into the machine learning systems. So AIF 360 and Fairlearn, this actually two of the big ones. So AIF is AIF 360. They're one of the very first tools that's kind of comprehensive and trying to solve the problems. They have this reweighting technique, and also there's Fairlearn also have correlation removal techniques. And with both, with this particular, I would recommend go to AIF 360 due to the simplicity of reweighting comparing to correlation removal. And there's also in process, and that's like trying to solve the, trying to mitigate bias during the learning algorithm learning stage. Post-processing, including threshold optimization or calibrate the equalized out. So equalized out is one of the metrics being used to access the fairness. Meta-process, it's only implementing in Fairlearn so far, and they have the research, so there's a trade-off in between bias and performance. And I know I don't have much time, so I do want to dive into model card. So there are a lot of the technical tools that you can use, but I think model card is a very example, because we need to understand that regardless what you try or what tools you use, it's really hard to completely mitigate, completely remove the bias there, because it's almost impossible. It's almost there, always there. So model documentation becomes very important for all your machine learning projects, especially those ones that's impacting humans' life. It's very important to have documentation on what data was used, how the data was used, and the metrics evaluation, understand limitation, and very importantly, the ethical consideration. So when you have this good documentation, so the people, not just data scientists, but business users, they are able to understand what's being used for your model. And this is one way to build the trust between the users and between the data scientists.
With accuracy for models, we measure against what types of accuracy humans would have been able to achieve to see if a model is good enough for deployment. Is there something similar for these types of problems? How biased a model is versus how biased the system would have been if the model didn't exist?
That's a really good question, because a lot of bias we're talking about with machine learning systems, they actually exist in real world, in human life as well. Like people make those bias decisions, and we like even recruiting process is biased when human, like we are able to see other people's gender, and like we judge people there. And the problem is we know human are biased, but with machine learning, it's almost like it's algorithm there. And I think it's almost important to treat machine learning as humans when they are making decisions, that you understand those machine learning systems, they actually learn from humans. So there can be bias there. So, and that's a problem. Like previously, without diving into this, we tend to just trust machine a lot more, because it's like, how can machine be biased when it's like just learning things, when it's just algorithm, right? And so this is really to bring the awareness of there's bias there, and does not mean there's no bias in humans' decision when it's human making decisions themselves. But I think people are very aware of that, and we need to bring that awareness to people building machine learning systems as well as people using the machine learning systems. And that's why the documentation eventually becomes the key